children, welcome to your home school. How are you all? This is your next session of your class 9 NCERT or CBSE mathematics. Okay, in this session we are going to start with a new chapter, that is your lines and angles chapter 3. So before starting our chapter, we need some tiny introduction, right? So we are going to see the introduction, that is about angles and what are the lines. What are angles? There are many types of angles. What is an angle? So, how do you measure this angle? Angle is measured in degrees. You know an instrument. What is a mathematical instrument? That is protractor, which is used to measure an angle. What is an angle? Two rays. One ray is in this direction and one ray is in that direction. Two rays are arising from a common end point. Point, you know, right? What is a point? It is used to represent the position. Okay. So now this two rays, we call them as the arms of an angle. What are those, children? Arms of an angle. And this point is called as a vertex. And how do we measure angle? See here, there is an arrow mark I am showing here. It represents the size of an angle. It is measured in degrees. That is x degree. Right? So, here what is happening here? So, angle, it makes an angle. These two are the arms and this is a vertex. It is creating an angle. Let's see the angles here, children. This is your protractor which is used to measure the angle. Let's start our angles with this. This is also one of the mathematical instruments, that is skiver. First, we start our types of angles with this. So, observe here, this is the point. So, observe here, children, this is the point. And from this point, two rays are overlapping on one another. So, two rays are overlapping on one another. It doesn't create any angle. Does it create any angle? No. So, this type of angle is called as a zero angle. What is this angle, children? Zero angle. Observe here, these two arrows are one above the other, which are fixed from one point. Okay, they are not moving any side. The two arms are emerging from the same point or on the same line. Right? So now comes to your acute angle. Observe here carefully, your point is here. Right? So now I have done, and it creates an angle. What is this angle? This type of angles, I call it as a acute angle. Why it is acute? Same point, same, and two arms are all same. Then what happens? The measure of the angle, what it will be? It will be 0 less than x degree less than 90. That means this angle is more than 0. Understand the sentence here? It will be more than 0 degree and it is less than 90 degrees. Acute angle is always more than 0 and less than 90. It might be 5 degree, 10 degree, 18 degree, whatever it might be. This angle will be less than 90 and more than 0. All these angles we call them as acute angles. So, see the next angle, children. So, what did I do here? I made this two arms perpendicular to one another. Perpendicular to one another means this arm is perpendicular to this line. Perpendicular, what do you remember? 90 degrees, right? So, look here. Can you see this? So, this angle is how much? 90 degrees. Okay, whereas here there is a condition, but here there is no condition. Okay, from here the angle is measured, the angle must be more than 0 and it will be less than 90. But here the angle is fixed. What is that fixed angle? That is right angle or 90 degrees. What is the right angle? The angle between the two arms is 90 degree. So next angle, what is the next angle? Look here children, little. What is this angle? You can see here, right? From 0 it is starting, acute it crossed, right angle it crossed. It's not perpendicular, 90 also finished. Then what is this type of angle called as? It is called as obtuse angle, right? So what is this angle here children? Look here. This is your obtuse angle. What is obtuse angle? The angle, suppose you may take anything here. Y is equal to is more than 90 degree and y is less than 180 degrees. How can you write this condition here? That is 90 degree is less than y less than 180 degree. That means this angle is more than 90 and less than 180 degree. These type of angles are called as obtuse angles. So observe here children, once again let's come back. 0 angle, acute angle, right angle, obtuse angle, right? So now look here carefully. What am I doing? Yes, what is this? It is a straight angle. 0, acute, right, obtuse, finished. Now what is the angle it is created? That is called as straight angle. Vertex. Two rays are emerging in opposite direction. One ray moving this side, another ray moving this side. This is called as a straight angle. Straight angle, what is its degree? That will be 180 degree. It will be fixed. So from here your angle starts and this angle will be 180 degree. What is your Z angle? Z is equal to 180 degree. So here X condition there. So let me take here P. Angle P is equal to 90 degree and whereas angle Z is equal to 180 degree you can say. And here Y angle is more than 90 less than 180. So now observe here. So now what am I doing here? Look here. Your angle started from here, right? Again, say for me. Now, yes, 0, acute, right, obtuse, straight, right? What is the next angle? Now, what am I doing? I'm rotating, right? So, where is this arm started? From here, it is revolving like this. Right? It is creating an angle. One side it is acute, but don't consider this angle. You need to consider this angle. What type of an angle it is? It is called as a reflex angle. So observe here carefully. So a point, one arm is here, another arm rotated and then it came like this. So angle started from here to here. Right? So angle is started from this point vertex to rotated and it creates an angle. What is this angle called as? What is this angle children? Reflex angle. Okay. So now, totally it has done one complete revolution and came like this. Then what is this type of an angle? Don't say 0. 0 is overlapping on one another, but after rotating completely, see here, from here this arrow moves like this and again if it is overlapping, two arms are overlapping on one another. So if nothing, no direction there, it will be 0 degree. If I am showing any direction, can you see the direction here? The ray or the arm starts its angle from here to here, then it is overlapping on a same line, creates a complete angle. Okay, this arm rotated full complete one revolution it has done, right? So this type of angles are called as the complete angles, right? What is a complete angle? What it will be children? So let's take here M. Angle M is equal to 360 degree. Then whereas this angle, let's take N. greater than 180 and less than 360. How can I write this? 180 degree is less than angle N less than 360 degree. Okay, let's recollect all the angles here. So there are two arms emerging from a common end point. It creates an angle 0, that is 0 angle. So now more than 0, less than 90, acute angle. So your angle is 90, then which type of an angle it is? Right angle, right? More than 90, less than 180. So which type of an angle is this? Obtuse angle, right? So now observe here carefully, what is this angle? More than 90 and it is 180 degree. Okay, it is a straight angle. So this is called as a straight angle. Okay, so next. Now what type of an angle is this? This is more than 180 and less than 360 degrees. So these type of angles are called as reflex angle. If it have done complete one revolution, then that is called as a complete angle. So once again, 0 degree, 0 angle, more than 0, less than 90, acute angle, 90 degree, right angle, more than 90, less than 180, it will be obtuse angle. And if it is 180 degree, straight angle, more than 180, less than 360, reflex angle. If the angle is 360 degree, then it is called as a complete angle. So you know children, this is the instrument used to measure an angle, right? So look here, with this we are going to see now all the angles. And what is this? So observe here, this is 0. You can see two scales overlapping on one another. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Can you see here? Like this. Okay. So again another scale emerging from this side to this side. Right? So two scales are overlapping on one another. So observe here, from 0, if your angle you are seeing from here, this vertex should be placed here. Okay, from this line, this is 0 degree. So this is called as a 0 angle. If I place a point here and if I draw a ray, then this will be acute angle. If it is, then this makes acute. If this is perpendicular, 90. More than 90, it is obtuse. If it is 180 degrees, it is straight angle. When you are measuring your angle from here, like this, you have kept your protractor. Suppose, if you need to measure an angle this side, there also you need to mark at the center itself, right? The vertex should be placed here, right? Now, you need to mark any 60 degree. From 0, you need to mark. Don't try to measure your angle from this side. Your ray is this side. So from this 0, you start measuring your angle. Okay. How you measure, you need to observe carefully. So now this is 0. Then like this you keep here. What is the angle of this? Observe here children. It is 60 degree. It is acute. So now look here. It is 90 degree perpendicular. And then it is on the same line, it is 180 degree. So this is how much here children, like this measure your angle here. It is from here you need to see 0 to 140 degrees is the angle, that is more than 90, less than 180 degree. Like this you need to measure your angle with the protractor. And some more terms we are going to learn children. That is collinear points. What do you mean by collinear points? You have seen already. What are collinear points? The points, this is a line, right? So if you mark some points on this line, so how many points you can mark on this line? You can mark as many points you want, right? So all these points, so let's mark here A, B, C, D, E, F, G and your line X, Y, right? So how many points you can mark? Infinitely many points you can mark. But where are these points? All are lying on a same line, right? So these type of points are called as collinear points. What do you mean by this children? the points are all lying on a same line are called as a collinear points. What is its opposite? Which doesn't lie on a same line? They are called as non-collinear points. So look here. Are they lying on a same line? No. So therefore these type of points are called as non-collinear points. If you try to join, will it form a line? No. So these type of points are called as non-collinear points, and these are called as a collinear points. So complementary angles. What do you mean by complementary angles here, children? If the sum of any two angles. So let's take any angle, children. Angle A plus angle B is equal to how much? 90 degree. If the sum of any two angles is 90 degree, then those type of angles are called as complementary angles. So look here how they will be. So this is a 90 degree angle and this is a vertex, right? You all know. Suppose if one more ray is emerged from here. So what will be sum of this angle and this angle, children? It will be 90 degrees, right? So how can I write here? So let's write here A. This is B, C and D, a point here, okay? Somewhere a point on this ray. So now how do we write this? Angle BAC, this angle, plus angle CAD is equal to 90 degree. So what it might be? You may take here 20 degree, you may take here 70 degree. 70 degree plus 20, how much? 90 degree. So what is that means, children, here? The sum of the two angles or sum of the two angles is equal to 90 degree. Then these type of angles are called as complementary angles. And if the sum of the two angles is 180, those angles are called as supplementary angles. So same manner, let me draw a line here, children. So let me mark a point vertex here. Let this be another ray and this is another angle. So this might be 120 degree and this might be 60 degree. Right? So observe here 120 plus 60 will be how much? 180. Right? The sum of the two angles, if it is 180, then those type of angles are called as supplementary angles. So once again look here, children, if points are lying on a same line, those are called as collinear points. If they are not lying on a same line, non-collinear points. And if the sum of any two angles is 90 degree, they are called as complementary angles. And if the sum of any two angles is 180 degree, those are called as the supplementary angles. Same manner you can write A, B, C and D like that. You can say this angle plus this angle is equal to 180 degrees. L, M, N, P. So look here, angle MLP plus angle PLN is equal to how much here, sum? 180 degree. So observe here, this angle 120, this angle 60. 120 plus 60 will be 180 degree. So if their sum of angles is 180, what is the type of angle? It is supplementary angles. So let's see the next one. Adjacent angles. What are adjacent angles here, children? Side by side angles. Okay, what are side by side angles? The two angles which are having only one common arm in between. That means, suppose this is, okay, this is a point, this is one angle, right? So another angle is like this there. So which type of an angle it is? It's not acute. More than 90. Then which type of an angle is this? From here, this is moving in this direction. So this type of angle is called as obtuse angle. So for this angle and this angle, observe here carefully. For this angle and this angle, what is a common arm? common arm, this ray is for this also there and for this also there. Means if any two angles are having in between a common arm, so we can say those two angles are adjacent to one another. So what you can say here, children? A, B, C, D. B is called the vertex. Angle ABC is adjacent to angle CBD. Angle ABC is adjacent to angle CBD. Suppose if I draw one more angle here, that makes E. So now look here. Is this angle is adjacent to this? No, it is not adjacent. Why? The two angles should have a common angle. Suppose if this is missing, then I can say this angle is adjacent to this angle. Okay, both the angles should have a common arm in between. Right, with example we'll see next. So let's see the linear pair. What is this, children? Before we have seen these two are non-common arms and this is a common arm, right? Suppose if these two non-common arms make a straight line, then those two angles are called as a linear pair. What is a linear pair here, children? If two non-common arms, this is one arm and this is one arm, these two are not common. Why? In between there is one ray that is common for this angle and this angle, right? When non-common arms makes a straight line, then that is called as a linear pair. Or you may say that it is a straight angle. Straight angle, what is the sum, children? 180 degree. Linear pair also 180 degree. Then what is this sum 180 means? Which type of angles they are? They are supplementary angles. See, in a same, I'm saying three words here. That is linear pair. Two non-common arms makes a straight line or a straight angle. They are called as linear pair. Okay, linear pair of angles. And if this is a straight line, right, the sum of the angles will be how much? 180 degree. Why? It makes a straight line. The angle is a straight angle. It will be 180 degrees. Suppose if the sum of any two angles is 180 degree, those are called as a supplementary angle. So, what is a pair of angles here, children? Suppose if you have any two angles here. So, there is one common ray. Okay. So, this does not makes a linear pair. Understand here, these two non-common arms are not straight line. Whereas which type of angles you can say? Yes, they will be adjacent angles. They are side by side angles or they are adjacent angles, I can say. Suppose if this is 90 degree, children, observe here carefully. Oh, the sum of the angles make 90. Then which type of angles those are? They are complementary angles, right? So now I will give you only this part of an angle is 60 degree. Right? Find out this angle. You know total angle. Total angle is how much? 90. If this angle is 60, what will be this angle? 90 minus 60, it will be 30 degree. That makes the sum 90 degree. Understand the concept here carefully, children. What is that? In a pair of angles, you will be having two angles will be there. Suppose they give one angle, you need to find another angle by all the rules what you know. Okay, so it is a right angle, we know. If it is a right angle, it will be 90 degree. One angle is 60 given, then other angle will be 90 minus 60, it will be 30 degree. Okay, suppose one more example I am going to ask you. So you can say this, children, everybody. What is that? Suppose it will be 100 degree. Okay, what is this is your question. It is looking like you can see all the answers here. What is it? Yes, it is a linear pair. It is a straight angle and this angle is adjacent to this angle, and I can say these two angles sum will be supplementary. So what will be this angle? It looks like a straight angle. Straight angle is how much? 180 degree. One angle is 100. Then what will be this one? 180 degree minus 100, it will be 80 degree. Right? This angle will be 80 degree. Like this, in a pair of angles, if anything given, you should understand the concept carefully. Let's see the lines, types of lines here, children. We are going to know this by taking a pair of lines. Pair means two, right? So, types of lines we see here are intersecting lines, concurrent lines, coincident lines, parallel lines, and non-parallel lines. So first, when we talk about intersecting lines, so you remember, children, you know what is a line? Yes, there is no end for this, and arrowheads indicates it extends indefinitely, right? So now I am showing here two lines where these two lines are passing through a common point, or that both the lines have one intersecting point, we say. These two lines meet at one point. That point we call it as a common point or intersecting point. So these two lines we call them as intersecting lines. Why intersecting? The two lines are intersecting at one common point. So now let's see the next lines. What is that? Concurrent lines. See here, concurrent lines. I am going to take more than two lines. 1, 2, 3, 4. Like this, what happens? So, many lines are passing through the same point. Okay. So, many lines are intersecting at one point. There is a common point for many lines. So, those type of lines we call them as concurrent lines. What is this? Concurrent lines. Intersecting lines, and this is concurrent lines. Next, coming to coincident lines. What do you mean by coincidence, children, here? Suppose let me take a line here. Okay, suppose let this be AB line. If I say there is one more line CD, two lines, look here, two lines. One more small line, can you see here? CD, big line AB. The two lines are overlapping on one another. Two lines are lying on a same line, right? So, two lines are there in a single line. That means we call those type of lines as coincident lines. So, next, very important, parallel lines. What do you mean by parallel lines here, children? So, let me draw two lines here. A, so let me mark here A, and this is B, and one more line if I draw C and D. So, what are parallel lines here? Two or more lines are extending indefinitely and they never meet. Suppose if I extend these lines, what happens? In the same way, they will be extended. But are they meeting at any point? No. So, if they are extending like this or this side, they will be extending parallelly, but they never meet. And these two lines are having no common point. Whereas when we call these two lines a parallel, when these two lines are extended indefinitely without having any common point and they never meet, those type of lines are called as a parallel lines. So here, children, how do we represent parallel here? With an arrow mark again in between these two. So this line AB is parallel to CD. How do we write this? How do we say? AB parallel to CD. AB parallel to CD, or CD is parallel to AB. So now comes under non-parallel lines. What are non-parallel lines here? The two lines. Suppose look here carefully. So there are two lines. when extended, they may meet at one particular point. Means the two lines are going to intersect at one point. Then this type of lines are non-parallel lines. See here, these two are non-parallel, and here these are also non-parallel. Okay, so here what happens? These two lines, when extended, they are not going to meet at any one common point. So if two lines are extended, they doesn't meet at any one point. There is no common meeting point, right? They extend indefinitely without meeting. So these two lines are parallel. These two lines, if extended, they too will meet at some place or some position. They are going to meet. Let's see here. Suppose this line is extended like this and this line is extended in this direction. They are going to meet at one point, forms an intersecting lines. Right? So these type of lines are called as a non-parallel lines. What are intersecting lines? If two lines are having the same common meeting point, we call them as intersecting lines. More than two or three lines are having the same common point, those we call it as a concurrent lines. And so two lines are overlapping on one another, those two we call it as coincident lines. And if they are not meeting at any point, those two lines are parallel. If they are meeting at after extending, if they meet at any position, then these two lines are non-parallel lines. So look here children, now we are going to learn about what is a transversal and how it is dividing into many angles. So look here, transversal, it is a line. So observe here carefully. I'm going to draw a transversal. What is this transversal? It is a line. It is a line passing through two different points in between two lines. Okay. So we call this line as a transversal. Transversal. Right? And these two are different lines. Suppose you may take the two lines are parallel or non-parallel also you can take. So that means if I take like this, any two lines, are they parallel? No, the distance between them is not equal. That is different. If it is extended at some position, they are going to meet. Right? They are not parallel. But on this also I can draw a transversal line. What is a transversal? It is a line which intersects at two lines at different points. So here now I am going to talk about a transversal drawn on two parallel lines. So now what does it do? I am going to show you here. It creates many angles here children. A transversal, when it is drawn on two parallel lines, it makes many angles, and what is the relation between them we are going to discuss now. So now let me start your angles like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are many types of angles will be divided here. So observe here children, you will be able to understand all the angles at one position here itself. Okay. So now look here. This angle 1 is touching angle 2. Angle 1 and angle 2 are sitting side by side. Just imagine here, you and your friend are sitting side by side. So that means your friend is adjacent to you and you are adjacent to your friend. Right? The same manner, this transversal, what does it do? It is dividing a straight angle into two angles. Yes or no? Suppose if I take only this line, it is a straight angle. Straight angle is divided with one ray. So what can you say? This is a straight angle or a linear pair also you can say. But sum of these two angles will be 180 degrees. Right? So understand here carefully. So what I am going to say now? Adjacent angles. Adjacent angles are nothing but side by side angles or beside angles you can say. So look here. Angle 1, angle 2 adjacent. Okay. Angle 2, angle 3 adjacent. Angle 3, angle 4 adjacent. Angle 4, angle 1 adjacent. Adjacent means what you are saying, every pair, this side fellow you can say, he is sitting near you or he is sitting near you, you can say. Suppose Ramu, Ravi, Rohan, three people are sitting. Ramu, Ravi, Rohan. So Ravi is adjacent to Ramu and Ravi is adjacent to Rohan. But whereas Ramu is not adjacent to Rohan. Are you understanding here? What is the concept, children? So the middle person is adjacent to either this person or that person. But the corner people are not adjacent. Are you following here? Now see here, this example, understand very carefully. Every pair of angles, I say them, they are adjacent to one another. That is, angle 1 adjacent to angle 2 or angle 1 is adjacent to angle 4. So look here, how can you write here? Angle 1 is adjacent to angle 2. Angle 2 is adjacent to angle 3 or angle 1. Angle 1 is adjacent to angle 2 or angle 4. Understand the concept here? Angle 1 is adjacent to angle 2 and also angle 4. Angle 2 is adjacent to angle 3 or angle 1. Angle 3 is adjacent to angle 2 or angle 4. Angle 4 is adjacent to angle 3 or angle 1. So many angles you can say. All side by side angles are all adjacent to one another. Right? So same manner, can you say this? Angle 6 is adjacent to angle 5 or angle 7. Angle 5 is adjacent to angle 6 or angle 8. Angle 7, angle 6, angle 8. Angle 8, angle 7, angle 5. Now look here, children. We are going to see next. What are the corresponding angles? So look here. Corresponding angles. What are corresponding angles? How can we observe here? Look here carefully. Angle 1 corresponding to angle 5. Angle 1 corresponding to angle 5. Look here carefully. Angle 1, angle 5. This side, angle 2, angle 6. Right? Angle 2, angle 6. So still if you want, you can see these angles also. Angle 4 corresponding to angle 8. See bottom angle and here bottom angle. So how can you say? Angle 4 corresponding to angle 8. Angle 3 corresponding to angle 7. Okay. So these corresponding angles we see here. How do we say, children? So see here this point, this angle and same this position, this angle we call them as corresponding angles. Angle 1, angle 5, angle 2, angle 6, angle 4, angle 8, angle 3, angle 7. Those are all called as the corresponding angles. Angle below the angle between two parallel lines, we call them as corresponding angles. Next angles are VOA. What is VOA? Vertically opposite angles. Vertically opposite. Look here, children. Angle 1. This angle is opposite to this. This angle is opposite to this. That is, angle 1 is opposite to angle 3. What are vertically opposite angles? Pair identify, I say. Angle 1 opposite to angle 3. Angle 2 opposite to angle 4. So reverse also you can say, children. Angle 3, angle 1, angle 4, angle 2. So similarly, look here. Angle 5, vertically opposite angle identify here. Angle 7 and angle 6. What is its vertically opposite angle? Angle 8. See here, adjacent angles are all side by side angles. Corresponding angles are the angles which are in between two parallel lines. Right? Those are corresponding angles and vertically opposite angles. The angle which is exactly opposite to one another. So next angle we are going to learn is alternate angle. What are alternate angles here, children? Alternate angles. These alternate angles, if you want, you can remember Z shape also. So how do you see here? What are alternate angles here? Alternate angles are in between. Alternate angles. What are alternate angles? alternate angles are found in between two parallel lines. When a transversal is drawn, the angle, look here, the angle is on opposite sides of a transversal. The angles which we see, look here, angle 4 on this transversal and other side of the transversal, what is the other side? 6. Angle 4 is alternate to angle 6 and angle 3 is alternate to angle 5. Alternate angles are found in between two parallel lines where these angles are equal. These alternate angles are on opposite side of the transversal. Whereas I cannot say angle 3 is alternate to angle 4, we cannot say. So which are the alternate angles here? On the opposite side of the transversal. One angle here means another angle should be here. These two angles are equal. That is angle 3 alternate to angle 5. In between two parallel lines we call them alternate. If they are not parallel we can't say those are alternate. So in between these two parallel lines, opposite side angle of a transversal, angle 3 is alternate to angle 5, angle 4 is alternate to angle 6 and these angles are equal. Whereas vertically opposite angles are also equal, children. Angle 1 equal to angle 3, angle 2, angle 4, angle 5, angle 7, angle 6, angle 8. See here, all corresponding angles equal, vertically opposite angles equal and alternate angles are also equal. So now one more thing we need to remember is sum of the interior angles on a same side of a transversal. What is the statement here? Sum of the interior angles. Now observe here, this is exterior, children, outside, right? This is also exterior angle and this is exterior angle. This is also exterior angle. So the angle which is in between two parallel lines, I call them as interior angles. I call them, these four are interior angles and these two pairs, 4 angles are exterior angles. So look here, a transversal divides two parallel lines in such a way that it forms 4 interior angles and 4 exterior angles. So one more very important statement we need to remember here. The sum of the interior angles on one side of a transversal, either this side or this side. So that means, look here, children, sum of the interior angles of one side of a transversal is always 180 degrees. Either angle 4 plus angle 5 180 or angle 3 plus angle 6 will be 180 degrees. So many we can learn here, children. So how can we learn? Many angles we can find if you know these all rules perfectly. So let's see one example here. Suppose let me draw parallel lines, some angles I am writing here. Let it be 40. So look here, children, this is 40 degree. What will be this angle? What angle you can remember? This is a transversal, right? So look here, this is 40. In this right angle, this angle, it is a linear pair, right? Linear pair, sum of the angle or a right angle is 180. 180 means 180 minus 40, how much? This will be 140 degree, right? So now look here carefully. Corresponding angles are equal. This is 40. This will be 40. Okay. And now this is 140. Vertically opposite angle 140 degree. Observe here, children. Now what I said the statement here. The sum of the interior angles of one side of a transversal. Is it 180 or not? Yes, no? So same manner you can find remaining angles also, children. So now this is 40 and this is corresponding to this 140 degree. and this is vertically opposite 40 degree, and this is 140 degree. See, all angles may not be same. Some angles might be different. See the axioms 3.1. If a ray stands on a line. So look here, there is a line, right? Suppose, let me take here AB is a line. If a ray stands on a line AB, then the sum of two adjacent angles so formed is 180 degree. What do you mean by adjacent angles? You already have seen now. What is that, children? Having one common arm in between two non-common arms. Okay, so what are adjacent angles? The two angles having a single common arm. So these two are adjacent angles. But now what is our axiom says? If a ray stands on a line, then the sum of this angle and this angle, the sum of these two adjacent angles is 180 degrees. We already know that. What is that? Suppose if I take angle here x and this is y. So I can write x plus y is equal to 180 degree. Angle x plus angle y is equal to 180 degree. So what's your axiom 3.2, children? If the sum of two adjacent angles is 180, okay, then the non-common arms of the angles form a line. So I think for this line, converse is this axiom. What is that, children? If a ray stands on a line, then the sum of the adjacent angles is 180 is this axiom. If the sum of two adjacent angles is 180, then that says that ray is standing on a non-common angles. Okay, non-common angles of the angle form a line. First one line given, they are adjacent angles and sum is 180 set. And now they are adjacent angles and sum is 180 such that these non-common arms make a straight line. Okay, these two are the axioms. And we have one more theorem in this. Before starting this chapter, we have theorem number 3.1. So these two axioms, So these two axioms are nothing but a linear pair. Same figure you can take for this also. If the sum of two adjacent angles is 180, then it forms a straight line. So now coming to your theorem 3.1. If two lines, there are two lines here, observe AB and CD. Okay, we have seen what are parallel line, what are intersecting lines, what are non-parallel lines. We have seen, children. So once again, we are going to see what is this angles. If two lines are intersecting like this is a line, this is a line. If two lines are intersecting means what? Two lines are meeting at one point. If these two lines are intersecting each other, then the vertically opposite angles are equal. So what is that? This vertically opposite angle. Look here, common point. This angle is opposite to this and this angle is opposite to this. You need to prove this theorem. How can we prove this theorem? Very easy. So what is that? Look here carefully. So I can write this angle O, right? So let's start here our data. What is the data given here, children? There are two lines. AB and CD are two lines. Given AB and CD are two lines. If you want, you can represent like this also. AB and CD are two lines. They are intersecting at O. Intersecting at O, they are intersecting, right? So next, what we need to prove them? What we need to prove here, children? They are the vertically opposite angles are equal. What is the proof? Are two angles O. O is the intersecting the lines where they intersect now. So that is O is the intersecting point I have written in data. Next, what you need to do? To prove. Construction, anything done, you can write there in the construction part. Now, what I need to prove? The vertically opposite angles equal I need to prove. So, that means either you may prove angle AOD is equal to angle angle COD, or look here children, COB, or you can prove this one, angle AOC is equal to angle BOD. Any one you can prove children, that makes vertically opposite angles equal. So how do we start our proof? Let me take any two angles first and then side by side other two angles. Then what happens here? Observe carefully. Okay, I'm going to give you a hint how do we prove this theorem. So first step, I'll consider these two angles. This angle plus this angle. So what you can say, these two angles are lying on a same line. That means these two sum will be 180 degrees. Okay, so listen carefully. This plus this angle is 180. So next step, I'm going to take this line, that is AB line I'm going to take. So that means this angle plus this angle is equal to how much? 180 degree. Right? So now when you are going to equate, if equals are, so by axiom 1, things which are equal to the same thing are equal to one another. So 180 equal, then what I can say? This angle is common for these two angles. I can say these two are equal. Finally, I can say vertically opposite angles are equal. So let's start our proof children. Just I have given you a hint how we can prove this. Our proof, let me start here. So look here carefully. Consider a line. Consider a line CD. Okay, in this line, I am going to consider angle COA plus angle AOD is equal to how much? We know. By what we know? By linear pair, I can say it is a straight angle. I can say these two angles sum will be 180 degrees. Mark this first equation, right? So next, consider. You have to consider another. What is that? Another. I'll take AB line. Consider AB line. In this AB, again two angles. What are those children? Angle AOD plus angle DOB is equal to how much? Again 180. Mark it to same equation, linear pair. So observe here, if I take CD line, this angle plus this angle will be 180 degree. If I take AB line, this angle plus this angle will be 180. Any one side you consider, right? So now what I can say from these two equations, I remember axiom number 1. Okay, what is that in your introduction to Euclids Geometry? Things which are equal to the same thing are equal to one another. So these two are equal. So what I can say, these two are equal. So which are equal here children? Angle COA plus angle AOD is equal to angle AOD plus angle DOB from 1 and 2 by axiom 1. From 1 and 2 by axiom, from 1 and 2 by axiom 1, what I can say? These two are equal. Understand carefully. These two are equal. So now, when you equate, what happens children? Angle AOD, same. That side, this side. If you bring that angle, this side, cancel. Right? Finally, what I can say? Angle COA is equal to angle DOB. Observe here where it is. angle COA is equal to BOD. That means the vertically opposite angles are equal. Hence, it is proved. So, once again, look at theorem, children, very tiny theorem. If two lines intersect each other, okay, then the vertically opposite angles are equal. You need to prove. What did they give? They have given the two lines. AB and CD are the two lines. They are intersecting at a point O. Okay, prove that. What we need to prove? You can take any one pair and you can prove. This angle is equal to this or this angle equal to this. You can prove. So now I have started my proof. How I have started, children? Consider a line CD such that this angle plus this angle will be 180. How? Linear pair. Now consider a line AB. This angle plus this angle will be 180 degree. Okay, see here, there is no restrictions here. Try to understand the concept. So, when you are considering CD line, you may take this plus this also. Okay, understand here carefully. When I take a CD line, either this plus this you can take or this plus this, but one pair only you take. Okay, again, if you take this pair, this plus this or this plus this you can take. Okay, so two lines. What I have done here, sum will be 180. There I remember axiom 1. What is your axiom 1, children? Things which are equal to the same thing. These are things which are equal to the same thing are equal to one another. So according to that axiom, I have equated these two. When I equate angle AOD will be cancelled. So what I am left with? Angle COA is equal to angle DOB. So therefore, these two are common. Cancel. Angle COA is equal to angle DOB. That makes vertically opposite angles equal. Okay, children, with this we are going to end our session today. In our next session, we are going to continue with this exercise. Okay, thank you all.